Good morning. This is a presentation that I gave at the BOINZ Symposium a week or so ago, and it's called Method Ledger. I'm introducing a new technology that I think can have profound impacts on how we comply buildings and other structures in construction. So let us start with the problem. How do you know that a building or building element complies with NZBC? And here we have a building consent official looking through paperwork, looking through models, looking through calculations, looking through product certifications, trying to figure out, trying to understand whether something complies or not. So it's not a great problem, and this person doesn't look overly happy. I have a solution, and it fits on one slide. I'm quite pleased, I guess, with this. The solution: always design and build everything the same. So if we use the same materials, if we use the same shapes, then everything would be so easy to comply. We'd all live in a pretty boring space, but you know what? Wouldn't it be easy to comply? I say that tongue-in-cheek, and this is put on the background of Sydney Harbour looking out from Circular Quay, which is obviously one of the least standardised cityscapes you could imagine. But just because the outer form changes doesn't mean we can't standardise the foundation and how it comes together. So here's a great example of standardisation. The standardisation of shipping is well known as one of the most transformational things to happen to logistics. The humble shipping container, right? And the shipping container was a standardized shape that allowed us to simplify and speed up the logistics of shipping. It didn't change the amount of things that we could put inside the containers. In fact, it's probably increased the amount of things that get shipped around the world. So that's what I mean by standardization. I don't actually mean to build everything the same. Question then becomes, what does a standardized container for construction look like? We're calling that a method. And the method consists of 4 important elements, which lots of different things can sit inside. So those 4 things being a compliance pathway. How do the things that fit in the container comply? Like, what's the legal compliance pathway that brings you to a conclusion of compliance? And then in the container, we have pre-engineered parametric product systems, an envelope of engineering that covers materials and equations and all sorts of engineering maths to make sure that this parametric product system complies with the physics that it needs to. Then we need another wall of the container. We need pre-appraised components and materials. We need a massive library of components and materials which we know their properties and we know their pedigree, and we rely and trust them. And finally, we need an auditable method history on the method itself, so as we can tell who looked at it when and what was inside it at that point. And there's your 4 walls. So thinking of the method now, let's move to another example of standardization. This one is from finance, from commercial transactions. And essentially, it's what happens when somebody issues a invoice and somebody makes a payment. There's something really important taken for granted here, and that's the value of the currency. The currency has already been determined, and the transaction and acceptance of that is so automatic, it's basically behind the scenes. It allows us to operate quickly across known levels of value. We might argue about delivery of services, the amount of the invoice, but no one is arguing the value of the currency or the way in which it would be reconciled. Might think it might be $5,000, but essentially we're going to negotiate and then press the button and reconcile. That's not what happens in construction at the moment. In construction, we're still at the time of barter, before currency was invented, where the compliance of every building element is negotiated every time we submit a design for consent. There's no common currency. We don't go, okay, I accept your evidence of compliance on face value because it's a known method, and I can therefore process compliance. We go, let me look deeper. Who are you? What did you do? What calcs did you do? What did you supply? What drawings did you supply? We're going into the value of the currency or the basis of the currency to try and figure that out. If we have methods, we essentially have the building code compliance requirements on one side. That's the equivalent of our invoices, which is a debt to be paid to building standards. And then we have the design and building elements, which represent the monies paid. And with methods, all we have to do is reconcile those two. We know exactly how much compliance we're looking for and what we're looking at. And if they match, we can tick it off. There's no need to look deeper into calculations or products unless there's a custom non-method design. And that's like someone paying for their pie down at the servo with foreign currency, and we're right back to barter again. In a ecosystem, it looks like this. Method ledger is a foundation technology, exactly what it says, a ledger of methods. Methods pre-engineered by engineers and pre-audited and approved by BCAs. Method ledger then automatically reconciles the underlying compliance transactions on projects. And you can see from the project site box on the right, there's a whole lot less engineers in that box. Their work is moved to a general pre-engineered layer as more and more building elements become kit of parts, modern methods of construction, or volumetric. Vision becomes that architects and contractors can drag and drop parametric, pre-engineered, pre-consented product systems into their specifications. Here's a quick look at what that might look like. This is from our pre-engineering platform called PRENGUIN, and this does pre-engineering for interiors, ceilings and walls. And what I'm doing here is I'm using our AI tool to pick the spaces off a drawing. Then I'm going in to our products, and I'm picking some product systems, pre-engineered product systems out, and pulling those out and dragging and dropping them onto the plan where they're immediately running compliance. I've done one braced ceiling and one fixed float ceiling. You can see the fixed float ceiling didn't work in this space, in this location, and the braced ceiling did. And now it's rendered out, and there's all the engineering calcs. Looking at the braced one here, and you can see where it's failed. The fixed and float one there, and you can see where it's failed. And the braced one, you can see how it's passed. All of that being part of the method in the background, all of that being seamlessly provided into the audit trail and the documentation for this project. And then we would run through and make the rest of the rooms red and green. And just showing here that only past markups transferred to plans. There is zero failed markups on this plan, zero failed designs, zero failed specifications get into the consent documentation in the first place. I think that is the end of this. And that's us. Essentially, I want to make BCA teams happy, like this guy here, who's just ticked it off, permit issued. I think Method Ledger has the ability to reduce risk, to reduce time taken, to increase margin, to increase consent compliance. To make it work, I'd need to make the audit process as simple and easy to do as possible while meeting all BCA requirements, and I need BCA help to do that. So when I come knocking, this is what I'm talking about, and I'll be very happy to talk to you all. Thank you for your attention, both at the BOINZ Symposium last week and also for this video here too, today as well. Have a good morning. See you later.